Perfect. Not good, not acceptable. Perfect. The kind of morning that makes you understand why people spend years of their lives and tens of thousands of dollars to stand on the slopes of a mountain like this one. Clear to every horizon. No wind. The kind of visibility where you can see the individual ridgelines of peaks 100 kilometers away. The team had been waiting for this for 11 days. 11 days intense, watching storms move through, watching the weather window they had built their entire schedule around shrink from a comfortable margin to something much tighter. The kind of waiting that expedition members describe afterward as its own form of suffering. Not dramatic, not dangerous, just the erosion of the timeline you built at home against the reality of what the mountain decides to give you. And then, this morning. They went. Of course they went. I want you to hold that for a moment before we go any further. The complete reasonableness of what they did. They read the conditions. The conditions said go. Every piece of training and experience they had accumulated over years of climbing said go. There was nothing in that morning that a competent, experienced mountaineer would have looked at and called wrong. The mountain killed 3 of them before noon. Not a storm, not a fall, not any of the dangers that every climber on every expedition briefing has described and prepared for and run scenarios around. The clear weather itself set the conditions that ended those lives. And this is the thing about Dhaulagiri that doesn't appear in the standard risk briefings, that doesn't come up in the permit process, that most people outside of the small community of climbers who have spent extended time specifically on this mountain have never heard stated plainly. On Dhaulagiri, the clearest weather of the season is often the most dangerous condition the mountain produces. Stay with me, because the reason is specific, it is physical, and once you understand it, you will look at weather windows on high mountains, and at risk more generally, in a way that is different from how most people look at them. If you're new here, subscribe. This channel goes into the actual mechanism behind what happens on extreme mountains, not the version edited for inspiration. 2 seconds. Dhaulagiri sits in western Nepal, 8,167 meters. It is geographically isolated in a way that most major Himalayan peaks are not. Deep river valleys on multiple sides, no comparable mass nearby to buffer what the atmosphere throws at it. The Kali Gandaki Gorge to its east is the deepest river gorge on Earth. To the north is the dry, high plateau of Upper Mustang. Warm, wet air from the south, cold, dry air from the north. Dhaulagiri stands in the middle of this, and it does not redirect what comes at it. It collides with it. The result is a mountain where weather builds and breaks in cycles that are more extreme and less predictable than on peaks with more conventional placement in the range. Storms that form faster. Temperature swings between storm cold and clear day warming that are wider than on most other 8,000ers. And large amounts of hanging ice, glaciers and seracs clinging to steep faces at altitude that are subjected to these cycles repeatedly throughout each season. Here is what those cycles actually do. During a storm on Dhaulagiri, days of cold, wind, precipitation, the mountain is loading. Snow is being deposited on the upper faces. Ice is accumulating. The hanging glaciers are getting heavier. But the temperatures are low enough that everything stays stable. Cold ice is relatively rigid. It holds its structure. The mountain accumulates stress, like a spring being compressed, but the temperature prevents release. The storm ends. High pressure moves in. The sky clears, and now the mountain is exposed to direct solar radiation for the first time in days. At 8,000 meters, with almost no atmosphere to filter it, that radiation is. The surface temperature of a south-facing ice slope on Dhaulagiri can rise 15 or 20 degrees Celsius within hours of sunrise on a clear day. The ice that was at -20 at dawn is approaching 0 by midday on the faces with full solar exposure. And here is the part that matters most, and that is least understood outside of high-altitude glaciology. Warming ice does not become safer. It becomes more dangerous. Cold ice is brittle but coherent. The crystal structure throughout the mass is tight. The ice holds together and transfers stress through itself as a unit. Warming ice becomes more plastic, more deformable, because the internal slip surfaces within the ice, the planes where one layer can slide against another, become lubricated as temperature rises. The ice starts to creep. Millimeters per hour, invisible from the outside. But the gravitational stress that has been in the hanging ice throughout the storm period, all of that accumulated weight and pressure, doesn't disappear while the ice warms. It has been held in place by temperature. Now temperature is changing. The spring is decompressing. Hit the like button right now if this is making you see something you didn't see before. One click. It tells YouTube this is worth showing to more people who've never heard any of this. The timing of Serac and avalanche release on Dhaulagiri follows a pattern that incident analysts have identified across decades of records from this specific mountain. Releases cluster in two windows, late morning to early afternoon, when solar warming has penetrated far enough into the surface ice to significantly change its mechanical properties, and late afternoon, when temperature begins dropping again and the thermal cycling between expansion and contraction creates stress in the surface ice that the warming alone did not quite trigger. Both of these windows fall inside the standard summit day timeline. A team leaving high camp at midnight, which is the standard start time for an alpine-style push on Dhaulagiri, is in the primary exposure zones on the upper mountain at exactly the moment the first window opens. A team that summits and begins its descent in the early afternoon arrives back at the most exposed sections of the route precisely when the second window is active. The weather window and the danger window are the same window. This is not bad luck. This is the same physical process expressing itself at different stages of the same day. The clear high-pressure system that makes the summit visible and the wind manageable is the same system that is driving the thermal cycle that loads the release window. I want to ask you something, and I genuinely want to know the answer. If you had waited 11 days in a tent on Dhaulagiri, if you had watched your window shrink, if the morning finally came clear and still and perfect, and you knew what I just told you about what clear weather does to this mountain, would you go? Write your answer in the comments. Not what you think the right answer is, what you would actually do. Now let's talk about the thing that makes this specific to Dhaulagiri, because this is not a universal truth about all mountains. It is a truth about this one, in this configuration, with these specific features. Most major Himalayan peaks have seracs. Most have loading zones. Most have some version of this thermal cycle. But Dhaulagiri's combination of factors puts it in a different category. The steepness of its faces means hanging ice masses are under more gravitational stress than equivalent structures on less steep peaks. The mountain's isolation means temperature swings are wider, colder during storms, warmer during clear periods, producing more extreme thermal cycling. The south-facing aspects that carry the heaviest serac loading receive the most direct solar radiation on clear days. And the specific geometry of the mountain channels, wind-deposited snow, into loading zones that are directly above the routes climbers use. Every one of these factors exists on other mountains individually. On Dhaulagiri, they exist simultaneously. And this produces a mountain that behaves, under clear conditions following a storm period, in a way that does not match the framework that most experienced Himalayan climbers carry with them from other peaks. Experienced mountaineers develop intuition. This is not mystical. It is pattern recognition built from hundreds of hours on glaciated terrain. They learn to read conditions. They learn to feel when something is wrong before they can articulate why it is wrong. This intuition is real, and it is valuable, and it saves lives. On Dhaulagiri, this intuition has a gap. The framework says clear weather equals reduced objective hazard. This framework is correct on most mountains most of the time. It was built from experience on mountains where it is correct. On Dhaulagiri, clear weather following a storm period is not reduced hazard. It is the mountain entering the active phase of its release cycle. The hazard is not behind the climbers in the receding storm. It is ahead of them, in the slopes that have been loading under cold temperatures and are now warming toward their mechanical threshold. And the climbers who arrive at Dhaulagiri with strong general Himalayan experience have no specific reason to distrust the intuition that has served them everywhere else. This is what makes Dhaulagiri different from mountains that simply have high objective hazard. High objective hazard can be navigated with appropriate caution. It can be briefed and prepared for. It produces visible and audible warnings that experienced people learn to recognize and respond to. Dhaulagiri's specific danger under clear conditions doesn't announce itself in the way that other objective hazards announce themselves. The seracs that release on warm afternoons following storm periods do not necessarily give the acoustic warnings, the deep cracking, the groaning that experienced climbers have learned to treat as evacuation signals. The thermal cycling happens below the audible threshold for most of the process. The internal slip surfaces in the warming ice are moving, but the ice is too massive for this movement to be heard until the moment it becomes fracture. And fracture on Dhaulagiri is fast. Survivors who were in positions to observe releases without being in their direct path describe the same thing across multiple incidents and multiple decades. The transition from stable to catastrophic movement is sudden, in a way that defies the usual model of avalanche or serac release, where there is some visible precursor event that allows a window for response. The ice holds, then it doesn't. The decision window is measured in seconds. Subscribe if you haven't yet. This channel covers the stories and the mechanisms that the mainstream mountain documentaries don't go into at this depth. It's free. The button is right there. And it genuinely matters for getting this content in front of more people. There is a question that sits underneath everything I have described here, and I want to address it directly rather than leave it implied. Is Dhaulagiri worth it? Not in the abstract philosophical sense about risk and reward and personal choice. In the specific practical sense. Given that clear weather, the condition you have been waiting for and that you need to summit, is simultaneously the condition that maximizes a specific and poorly signaled objective hazard, is there a way to manage this mountain that a reasonable person could call defensible? The climbers who have the best long-term records on Dhaulagiri over multiple attempts give a consistent answer. Yes. But not with the same framework you use on other mountains. The teams that have navigated Dhaulagiri's specific hazard most successfully describe a set of operational decisions that look conservative to the point of being overly cautious from a general Himalayan climbing perspective. They start earlier than standard. Not midnight, earlier. Getting through the most exposed sections before the first solar warming window opens. Not just before it peaks, before it begins. They set hard turnaround times that account not just for oxygen and daylight, but for thermal window exposure. The calculation is, not only can we summit and descend before dark, but can we summit and descend before the afternoon release window opens on the specific faces we will be traversing on the way down. And they accept a summit margin that is smaller than what they would accept on other mountains. The safety buffer that feels adequate on Everest or Choi or Yu is not adequate on Dhaulagiri, because the hazard they are managing is not linear with altitude and time in the way that oxygen depletion and weather deterioration are. It is step function. It doesn't gradually increase. It opens a window. Being inside the window is quantitatively different from being outside it. This is not a framework that maximizes summit probability. It is a framework that manages a specific hazard that most general Himalayan experience does not include. And it requires knowing this mountain specifically, not mountains in general. The team that went on that perfect morning, after 11 days of waiting, had strong general experience. What Dhaulagiri requires is specific experience. The mountain doesn't care which other peaks you have climbed. It doesn't adjust its thermal cycles based on your expedition record. It does what it does on clear mornings after storm periods. It has always done this. It will keep doing this. The question is not whether the mountain will release. The question is whether you will be on the face when it does.
All right, 2 things. First, drop a comment with which video you want next. Option 1, the 1986 K2 season. 13 dead in 30 days. The full sequence of what happened and why it happened in that specific order. Option 2, why Annapurna's fatality rate has never meaningfully improved, despite decades of accumulated knowledge. The structural reason it keeps killing at the same rate. Option 3, what Sherpas say to each other about the climbers who pay $100,000 to summit. The insider perspective nobody publishes. 1, 2, or 3 in the comments. Second, if this gave you something real, hit the like button. Not for me,